Morning class. We have today's lesson on compound inequalities using the words and or, followed by a couple word problems, and for the enriched section you get to solve absolute value problems with inequalities. Here's your first set of practice problems. Here's your second set. A bit more solvings involved here using and or. Couple notes, 2 short word problems. And the enriched section, you have these 6 absolute value problems to solve with and without the inequality symbol. Let's get started. So for the first part, we are to write a compound inequality without the word and. So in this case, if both of these have to be true, that's what the word and means, then you could write the x in the middle, making sure that the tail and the mouth point to the right direction, like so. This one is less than 5, so it can go here. And it has to be greater than 5, but less than 6. Like that. So for this one, you could even rearrange it to make it a bit more obvious, like swap this one and this one here. Then you have 2y on this side. 2 is less than y. And then over here, 2 is greater than, 2 is less than y and y is less than 6. So then you can combine these two together and get one inequality. Like so. M has to be less than or equal to 4, M has to be less than or equal to 6. This one, a little bit harder to combine. You can rewrite this one and make sure the inequality for this part points in the same direction. Okay. For this next problem, here's another technique. You could swap these two, but make sure that this symbol in the middle still points in the same way. So if you have n on this side, it's still the same inequality if you have the inequality open up this way. It'd be like so. Now you can see these two ends, so it's easier to connect these two together and get this final inequality. And we've dropped the and. It's the first case of a compound inequality using the keyword and. Biggest part, making sure the tails point in the same way and the mouths open in the right way. As we try to graph these, it becomes a multi-step process. First, we'll start by graphing each of these individually. So maybe something like this, where you have, let's put 0 here, 5 here, 6 here. You're going to have 5 being open, and then it's all things bigger than 5, so that's going to go this way. That's where your solution set's going to be for the first inequality. So here's x being bigger than 5. So having that same exact number line, we need a third time too. Having that same exact number line, now this thing is 6. It's going to be here, open circle, because there's no dash underneath. X has to be less than 6. It's going to go this way. These are the inequalities separated, and you notice right about here and here is where they overlap. In order for both of these things to be true, the number has to be between here. So your final answer looks like this. Okay. If we were to rewrite this inequality without the and, like we did from before, you'll notice that it becomes like this. X has to be bigger than 5, but less than 6. So here's your answer. So the process here is graphing each individual inequality and figuring out where they overlapped. That's how you graph the inequalities involving and. And is overlap. Both must be true. Here's your second problem. Here's your number line. Let's put 0 here, -4 here, +6 over here. Alright, let's get graphing. So here's the first inequality. M is bigger than or equal to 4. So now we have a filled in circle. If you're bigger than or equal to 4, you're going to go this way. Here's the other inequality. M has to be less than or equal to 6. We're going to go this way. M is less than or equal to 6. And you figure out where they overlap. Dot first starts here, then goes here. There's everything in between. So without the and, we have this inequality. And that's our answer for 2b. Bit more practice with the and. We'll start by drawing 2 number lines, or 3 number lines. Let's put 0 here, 2 here, 4 here, 6 here. Duplicate it. Something like that. Grab my pen. Here's your open circle for the first inequality. X has to be bigger than 6, so it goes this way. Or Y has to be bigger than 6. Y has to be less than 2. It goes this way. And we notice now the overlap, it would have been here, in between this area. But that isn't the case here. So if there's no overlap, that means we have no solution. We can't get both of these to be true. No numbers are both bigger than 6 and also less than 2. And if you say it that way, it makes a bit more sense. Numbers can't be both bigger than 6 and less than 2. Okay. It's a little different for the or. Or is just combining things together. We'll go through that same process. There's your number line. Let's put 0 over here, maybe -2 over here, 5 over here. this one I don't think we really need 3, but we're going to put them in anyways. Okay, so like from before, find 5. X has to be bigger than 5, not equal to, so it's an open circle. Bigger than goes this way. 2, negative 2 has to be less than negative 2, so it goes this way. And for ORs, you just put them all together. So your final answer here, as we just stick them both together, because either can be true for an OR. And there's no shortcut to rewrite this, but your answer looks like this. Okay, there's your answer. ORs, I think, are a lot easier. ORs, only one of them need to be true, and in this case, you could be on this side, or you could be on this side. Last one. We have 2 and negative 2 and positive 4. Let's put negative 2 here, 0 here, put 4 over here, duplicate this. Well, why don't I just use the same number line for this one? So negative 2 is on this side. Everything has to be less than it. So it goes this way. Positive 4 is over here. Has to be equal to, so we fill it in. And goes this way. Oh, bigger. And together, that's your answer. X is less than 2. Open circle. Y is greater than or equal to 4. That's all. Often with the ORs, you don't really need 2 number lines, or even 3 number lines. It's a little extra, but I wanted to show you all the steps. Next 2 problems involve solving, as we have one with the AND and one with the OR. So first, in order to make these a lot easier to graph, you want to get the variables on just one side. So we'll go through those motions. For here, we have to subtract 4. We're left with 3y less than 2. Divide both sides by 3. Y is strictly less than 3 over 2. That's one of our things that we need. Just trying to circle better. I keep overlapping my 2. Alright, there we go. For this side, add, there is a variable on that side, so I'm going to take away 2 as my first move. Do these go away? Negative 7 is less than 2y. Divide by 2, divide by 2. Y has to be greater than negative 7 halves. These both are connected with an AND. And now let's get graphing. So on one number line, it could look like this. Let's put 0 here, 2/3 here, 7 halves over here. It's okay if things aren't to scale. Here, 3 halves, everything less than that, so less than is going to go this way. And then maybe I'll switch colors. 7 halves is over here. Okay, so this is 7 halves has to be less than y. So y has to be the bigger thing, so it's going to go this way. Notice where they overlap. So our final answer looks like this. Open circle here, space in between them. Okay, fold it however you will, put this in the peach is your final answer. I'll do this one more time as we go to the OR. First solve. Been doing this most of this year. Divide by 3. X has to be bigger than 2. On this side, subtract 3. Subtract 3. You're left with 2x is less than negative 6. Divide by 2, divide by 2. You're left with x has to be less than negative 3. As you graph this on number line, let's put 0 here, negative 3 over here, and 2 over here. 2 has an open circle, everything bigger than 2, so you go this way. X has to be less than negative 3, open circle, less than 3. And in peach, for the ORs, you put them all together. That's your answer. Not so bad. As we move to our word problems, we now have to solve a couple things. So we have to translate these words into inequalities and then solve them. No graphing's required. But we do have to interpret the situation here. So in this problem, Kates wants to spend at most $25 for new stamps. He selected a new stamp that cost $3.50. How much can he spend on other stamps? Simple enough. So if he has $25, let's say X here is the amount he can spend on other stamps. If he already spent $3.50, at most is the less than or equal to sign. I think I gave that in my notes in the above, at most, so he can spend exactly $25. Okay. Or maybe in your heads you were thinking, okay, if he has X and he already had 25 and he spent $3.50, that means he's left with $21.50 to spend. He doesn't have to spend all that. He can spend at most $21.50. He could spend 20, he could spend nothing and save that for something else, a bit more interesting than stamps, let's say. That's what this sentence is saying. Jenny here has scores of 87, 92, 89, and 97 on algebra quizzes. What must Jenny's fifth score be to have an average score of at least 90? Here's our inequality hint, at least 90. So she could get exactly 90. And now we got to think about what it means to find the average of something. X is going to represent her fifth score. So there's her first, second, third, fourth, and here's her fifth score. Find the average. Since we have 5 scores, we have to divide by 5. And now we'll solve for X to figure out what's the minimum score she needs to get. Multiply both sides by 5. Let's add up all these numbers while we're going there. I'm grabbing my calculator. 87, 92, 89, 97. So that's 365 plus X is less than or equal to 450. Then it becomes a matter of subtraction. X has to be, did I do something wrong? No, this is right. 450 divided by, 85. So in order for her to get a score of at least 90, she needs to get, did I mess up on my variables? At least. That's why. I was like, wait a second, these symbols are pointing the wrong way. At least. So her average has to be bigger than all this. It's like, wait a second, you can't get a score less than 85 and still expect an A. So there's my mistake. At least it points this way. So she needs a minimum score of at least 85. 85 and higher will get her the grade she wants. Now for the enriched portion of the class, I have a couple things to say about absolute value inequalities. When you think back to what absolute value means, right? On a number line, when your things are equal, let's say 0 is here, you know you have your first answer of 2. But you can go to the left of the 0, because that absolute value is the distance from 0. You have a second answer, that's negative 2. Okay, 2 or negative 2. When you start applying the absolute value to inequalities, you think about this case, x has to be, absolute value of x is less than 2. So there's our two numbers. You think about, okay, it has to be less than 2, so there's your open circle. It's going to go this way. And now if you approach it, so that's our first inequality. This thing means x is less than 2, right? Just drop the absolute value bars. But now, you know that the second part of your answer has to be over here, right? This is the stuff that's less than 2, this area. So then, can't go beyond it. You have to go this way. That's what it looked like visually in the graph. And if you work backwards, you notice that that inequality is everything is bigger than negative 2. Both of these have to be the same, so there's an and here. And that's how we'll translate the inequality into the absolute value inequality into compound inequality. So when we say the absolute value of x is strictly less than 2, that's saying it's the same thing as x has to be less than 2 and x has to be greater than negative 2. In summary, when you have less than, means and. Okay, remember that. Again, we'll go through the exercise when we have the greater than symbol. There's 0, here's negative 2, here's positive 2. First case is easy enough. X, just drop the absolute value bars. X has to be greater than 2. So there's X. Oops. Open circle. Goes this way. Second part, we need it to look like this. Going to the left. So x here has to be greater than, x has to be less than negative 2. Because for the negative numbers, it's all things that are smaller. And we notice this graph, there's no overlap here, but we still want to combine them together. That's why you need the OR keyword. Saying the absolute value of x is greater than positive 2 is the same as saying this compound statement, this compound inequality. X has to be both greater than 2 or x has to be less than negative 2. So when you have greater than, that means or for inequalities, for absolute value statements. And you'll see this be applied in the next couple practice problems. The thing to highlight is this thing. You have to remember when you switch the signs, you also have to swap the symbol. And I'll show you an example of what that means. So this one, I think we practiced these at the beginning of the year. First problem looks like this. Add 3 to both sides. You get this problem, divide both sides by 4. You get p as 5/2. Your second answer, you rewrite it, -3, and then you make this one negative, and then you solve as normal, because to the left of 0 you could also have an answer. Okay, simple enough. The other way you can go about it is solve by dropping the inequality or absolute value signs. 4k equals -1, k equals -1/4. You could also solve it this way. Make this whole side negative, end up with the same answer. Only one side can be negative though. Okay, you could also just make it equal to -5, same thing. Okay, that's solving with the equal sign. And now, the new part is solving these inequality problems where it involves absolute value bars over here and this inequality symbol. So the first part, as you expected, is dropping the bars, leaving everything alone, solving 3x is less than or equal to 6, s has to be less than or equal to 2. That's the first part. This one, watch carefully, 3x minus 1. As you set it up, you have to flip your inequality and flip that number. So we'll make that in red. So you flip the sign of the number and the inequality here. Then you can go about solving it. 3x less than or equal to -4 now. So x is strictly or greater than or equal to 4/3. We notice we have a less than here, so that's the and. So both of these things have to be true when we graph them out. Let's put 0 here, 4/3 here, 2 over here. Things have to be less than 2, so it goes this way. Things has to be greater than, it goes this way. So that means the stuff in between, and we see the picture now matches, it's an and. Okay, 3 more practice problems. Solve this first one. K is less than or equal to 4. Like that. 2k minus 3. Flip. 2k less than or equal to 2. K looks like this. As we graph it, let's put 0 here, 1 here, 2 here, 2 has to be less than, so it goes this way. 1 has to be greater than, so it must go this way. Overlap here is your answer, and, because we have the less than symbol. As we move on, now we have the other symbol, greater than. So same idea, solve these things 6y less than negative 2. Y has to be less than 1 over 3. That's the first one. 6y plus 6. Flip the sign, inequality sign, and the sign of your number. 6y strictly less than minus 6. We have 10. Y has to be less than 5 over 3. We now notice this symbol means or from the notes earlier. We draw a number line. Things are all negative. There's negative 1/3. Here's negative 5/3. 1/3 bigger than it. Oops, don't fill it in. Bigger than 1/3 goes this way. Less than 5/3 goes this way. We know there's no overlap, so there's our answer. Last problem. For x minus 5 less than 3, for x is less than 8, x has to be greater than 2. I read those symbols wrong, my bad. Or, as that's what this symbol means, for x minus 5, swap the sign of this inequality and the number. For x plus 5, 2. Great. Graph our number line, there's 0. Let's say this is 1/2. Over here is 2. 2 has to be less than this one. Oops, don't fill it in. That goes this way. Here's positive 2, must be bigger, and there's our answer here. That concludes today's lecture.